Okay, so here's some selected problems from the review. Making a video. This should be pretty representative of everything that's going to be on there. So we've got r squared minus 7r minus 30. We are looking for the factors. We're looking for the things that are going to multiply together to make this negative 30, add together to make the negative 7. If we make a full factor tree, we're looking at a negative 30. That's going to factor to negative 1 and 30, 1 and negative 30, negative 2 and 15, 2 and negative 15, negative 3 and 10, 3 and negative 10, negative 5 and 6, 5 and negative 6. The combination, that's all the things that will multiply together and potentially make negative 30. So when I go through those factors, I'm looking for the pair that's going to add together to make a negative 7. In this case, it's a positive 3 and a negative 10. So I've got a positive 3 and a minus 10. Since it's r squared out front, this should be r minus 10 and r plus 3. If you were doing this before and you just made this into like all of them were x's, I'm okay with that. I don't have a problem with that. I believe everything on the test is just x, and it doesn't really matter because it's either matching or multiple choice. All right? Someone open the door for... Okay, on the next one, this is kind of important. We have r squared plus r minus 56. If you're looking for this, it's what's going to multiply to make a negative 56, but what's going to add together to make a positive 1. If there's no number in front of that variable, it has to be a 1. So in this case, that's going to be a positive 8 and a negative 7. A positive 8 times a negative 7 will give us a negative 56. And then a positive 8 minus 7 will give us a positive 1. That's r plus 8 and r minus 7. Skipping down a ways, we get to number 13, which is 7a squared minus 49a minus 210. Now, this one has a GCF, a greatest common factor. It's divisible all the way across by one number, and that number is 7. So I'm going to divide out that 7. I get a squared minus 7a minus 30. But I cannot ignore the 7 that I factored out. That has to be part of my answer. It belongs there. Then once I've got that, I have factored out my GCF. Now I look at what I have left in the parentheses. I can still factor this. And if you look at this, actually, except for the letter, it's identical to number 1. What's going to multiply together to give me a negative 30, add together to give me a negative 7, it's still negative 10 and positive 3. This is just going to be a plus 3, a minus 10, and the 7 that I factored out to start with is still a part of my answer. It doesn't go away. It doesn't disappear to some other dimension. It's part of my answer. Now, this being a multiple choice test, there are odds on that there's going to be a problem like this, where there is a GCF, and it will put just these two factors, a minus 10 and a plus 3. But remember, you have to be able to take all of the factors, multiply it together, and get back to what you started with. Without the 7 in front, without this being there, this will not multiply back together to make 7a squared minus 49a minus 210. Although I looked at the test and like all 4 versions of the test, and the largest number that's going to happen in front of that a squared, I think, is a 15. Okay? So it's not going to get that crazy. Most of the rest of these down through here on the front of this page, from 13 on, have greatest common factors, and they're going to work the exact same way. However, I would like to point out number 18. Number 18 does not have a GCF. Take that, tape dispenser. Number 18, though, is missing the b value. Number 18 is going to be difference of squares. So we're looking at square roots here. What's the square root of 36? That's going to be 6. The square root of x squared is x. What's the square root of 25? Square root of 25 is going to be 5. We have 6x and we have 5. The fact that we don't have anything in the middle means it's going to be opposites. One of them is plus, the other one is minus. Okay. Again, we're kind of hitting some highlights on this video. Yep. On the back side, we do have more difference of squares. If you look at number 21, very important to remember that 1 is a perfect square. So in this case, I have 9k squared. The square root of that is 3k. And I have 1. The square root of that is 1. So this is going to be 3k plus 1 and 3k minus 1. All right? Difference of squares. One of them's plus, the other one's minus. Other than that, they're identical. Be careful when you get to ones like 25. 25 is set up like it should be difference of squares. Problem is, neither one of these values is a perfect square. However, it has a GCF of 2. If we factor out the GCF of 2, we end up with 9n squared minus 4. 9 and 4 are perfect squares. So this is going to be 2 times 3n plus 2 and 3n minus 2. Again, difference of squares. It's the exact same factor. The only difference is one of them is positive, the other one's negative. Okay? Now, I'm going to skip down to one of these down at the bottom. There's plenty like this one on here, but none of the others have quite as much room to work. So that's why I'm using this. If we have a number in front of that x squared out front, the other method of saying, okay, what's going to multiply to make the last one and add together to make the middle one is not going to work anymore. So what you have to do here is use the MAD method. So we start by multiplying 3 times negative 5. 3 times negative 5 is going to give us a negative 15. So I'm looking for what's going to multiply to a negative 15 and add together to make a negative 2. The factors that are going to work for that are going to be a negative 5 and a positive 3. A negative 5 and a positive 3 will multiply together to make negative 15 and then add together to make a negative 2. So I write these like they are normal factors. It's P. P minus 5 and P plus 3. Then I'm going to divide both of these factors by my A value. Okay? It's not a set number every time. It's always the A value, which in this case is 3. I divide by 3. I divide by 3. If it goes in evenly, I write my result. 3 divided by 3 is 1. This is P plus 1. That's one of my factors. If it does not go in evenly, I make it move to the front. That's 3P minus 5. So that's my two factors for that. 3P minus 5 and P plus 1. Now, it may be that you're looking at that and you're thinking, the test is tomorrow, I'm going to fail, I'm terrible at trying to factor that out, there's no way I'm going to get it, somebody help me please. Okay? Here I come to save the day. This is a multiple choice test, which means all of the solutions, all of the possible solutions, have to include one of them that's going to be correct. If you can't factor, you can probably multiply. So if I'm looking at one of my potential answers, and one of my potential answers is 3P minus 5 times, what was it, P plus 1? Yes. If that's like letter A, all right? What I'm going to do if I can't factor is draw my boxes and say, okay, here's A. 3p minus 5 times p plus 1. 3p times p is 3p squared. P times a negative 5 is a negative 5p. 3p times 1 is 3p. And then 1 times negative 5 is negative 5. I have 3p squared minus 5p plus 3p minus 5. These are like terms. I'm going to put them together. So I go 3p squared minus 2p minus 5. Wouldn't you know it? When I multiply that together, this is the answer I get, which is what I started with when I was supposed to factor. If they multiply together and make the right answer, those are the correct factors. So if you struggle with factoring, then just perfect multiplying, and it should get you as far as you need to go on this test. Okay? Now, I have a key already posted. It's on the Google Classroom. I made it this morning. I scanned it in. I'll post this video on my YouTube channel and on the Google Classroom.
How do we know